Welcome to the Full Data Story. Today, we're going to reverse engineer a piece of everyday magic. We're diving deep into the exact data architecture that makes your favorite food delivery app spike its prices the very second a drop of rain hits the ground. Using some incredible deep dive insights from the two Layman Data Engineers podcast, we're going to meticulously break down this complex, invisible system, kind of like a tech documentary.
Let's set a scene we've all been in. You're sitting at home, it starts pouring outside, and you decide, hey, I'm going to order a pizza. You open your app, and bam, your meal costs 100 rupees more than it did literally 10 minutes ago. It's frustrating for sure, but what's actually happening behind the screen? How does the app instantly know it's raining, know you want pizza, and calculate that exact price hike so flawlessly?
To figure this out, we're taking an anatomical journey following a single GPS ping through a world-class data pipeline. We'll look at the surge pricing trigger, ingestion, processing, action, and finally, storage. Let's jump right in. Section 1. The surge pricing trigger.
So, in their trailer, the podcast host talked about three key streams of data: demand, supply, and context. Normally, the app just casually sends a GPS ping every 5 seconds. The system's totally relaxed, But then the context changes. It rains. Millions of hungry users open the app all at once, creating a massive, immediate spike in demand. At the exact same time, riders look at the weather, decide they don't want to drive, and log off, which instantly crashes the supply. This creates an absolute tsunami of digital events that would easily crush standard servers in seconds.
Which brings us to step 2, ingestion, the system's nervous system.
How do these companies actually catch this massive influx of data without their servers literally blowing up? Well, they use data ingestion. This nervous system relies on industrial-strength message brokers. We're talking heavy-duty tools like Google Cloud PubSub or Apache Kafka. These aren't your standard databases. They're massive shock absorbers built specifically to take the hit of internet-scale traffic. Think of PubSub or Kafka as a massive, high-speed conveyor belt. It doesn't process the data or run the math. It just catches those millions of sudden data drops and queues them up safely so nothing gets lost. It acts as an infinitely scaling buffer. So no matter how many desperate people open the app during that storm, not a single ping gets lost in the void. Moving on to Section 3, processing, which acts as the brain. A conveyor belt is great, but it isn't smart. We need a brain. That data has to immediately flow into stream processing tools like Apache Flink or PySpark Structured Streaming. If Kafka is the conveyor belt, PySpark acts like an army of rapid-fire accountants. They're aggressively pulling data off that belt in real time, doing the actual heavy lifting to make sense of the chaos.
To organize millions of scattered users, PySpark groups everything into what we call geohashes. Basically, a geohash is a digital neighborhood zone. Instead of looking at an entire sprawling city all at once, which would be overwhelming, the system chops the map up into tiny, manageable grids. That way, those rapid-fire accountants can see exactly what's happening right on your specific block.
And that's where we see the crisis at a local level. Let's say PySpark looks at your specific geohash and sees 500 hungry people repeatedly refreshing their screens, but only 10 active riders available. That massive, unsustainable imbalance, it instantly triggers a highly complex machine learning model known as the surge pricing engine. The brain runs a lightning-fast calculation on that overwhelming demand, the depleted supply, and the weather context to find the perfect price multiplier, say a 1.5x surge. This specific number is designed to do two crucial things. It tempts more riders back onto the road with the promise of higher pay, and it gently discourages a few users from ordering, which brings the whole system back into balance. Next up, Section 4, Action using fast NoSQL. The system knows the new price, but it needs to get that 1.5x multiplier onto your screen immediately right before you hit order. You absolutely cannot use a slow traditional database for this step, or the app would lag and the whole experience would break. Instead, it writes this new price to an ultra-fast NoSQL database like Redis or Cloud Bigtable, engineered exactly for rapid-fire, real-time querying.
Thanks to that NoSQL speed, when you hit refresh on your app, your phone reads the new price from Redis in single-digit milliseconds, literally the blink of an eye. You see the higher price, you decide to pay it, and the system averts a total platform crash without a single glitch.
Finally, Section 5, Storage, the data vault. Okay, you've paid the surge price and your pizza's on the way. But what happens to all that raw data?
It doesn't just disappear into the void. The raw logs, the weather context, every GPS ping, it all gets dumped into a massive data lakehouse vault. Companies use cheap, highly scalable cloud storage like Google Cloud Storage or GCS buckets to hold absolutely everything cost-effectively.
Once it's secured in the vault, data engineers step in. Using powerful tools like Databricks or BigQuery, they run this massive dump of data through what's known as a medallion architecture. They take the messy, bronze, raw data, filter it into silver, clean data, and finally polish it into pristine, gold, business-ready data.
And why go through all that effort? Because that gold data is incredibly valuable. Data scientists rigorously analyze this refined historical data to train the next, even smarter version of the search pricing model. They are quite literally using yesterday's rainstorm to predict exactly how you'll behave in tomorrow's rainstorm, constantly fine-tuning that multiplier calculation.
So here's the real takeaway. The next time you're gritting your teeth and paying 100 rupees extra for a pizza, remember, you aren't just paying for the food, you're funding a massive, invisible technological assembly line. You're paying for Kafka, PySpark, Redis, and a completely world-class data engineering pipeline running flawlessly in the background.
Hopefully, this explainer completely changes how you look at your everyday apps. Behind every simple tap is a symphony of complex architecture. So next time the sky darkens and prices surge on your screen, will you just see the rain, or will you visualize the incredible data pipeline running the modern world? Thanks for joining me on this deep dive into the full data story, and keep asking questions about the hidden systems all around us.